Round 3. Fight!
Good morning.
Good morning, everybody out there, and welcome to this live stream. How are we doing today, Martin?
Fantastic. Feel like working.
Yeah, we can see it on you. Eager to start. So right away, just switch over to the CAD then.
How are you doing, Hannes?
You know, I am so good. I don't know what it's with me today. I'm so filled up with energy.
I know what's with Hannes today. He just did like 140 kilo bench press with feet up on the bench and then 19 repetitions and 90 kilo afterwards. So that's what up with Hannes 3000 today.
Today I'm hyped.
So thank you for joining us. The objectives for this particular stream is that we are going to block with some global parameters. And this is something we started yesterday. And I have two purposes with this. So purpose one, see if the parameters behave. Because I'm going to control, hopefully, the whole machine across hundreds of design files from one list of parameters. But the purpose two, which I think we will get into pretty fast, is to find good instrument positions and gear positions. So let's get straight into it. What I have done is that I learned yesterday a way to share the parameter list across multiple Fusion designs. So what I made here is I made a skeleton design file. So this is like our master file. And in this file, so I wanted to show you like a quick little tutorial if you want to do this yourself. The way I've done it, maybe there's other ways to do it. So, and shout out to John Hackney, a YouTube channel that I learned this from yesterday. So let's just show to the left here. So you see as well over here in the menu, you see that we have different Fusion files. So in your parameter list, in your first main design, this is my parameter list right now. So these are all the measurements that I want to have propagating through a lot of Fusion designs. And I favorited them all. And what I do then is, because I just started this new design file, a compound shaft. And what I need to do then is that I go here in my master parameter file, I go to create and I go to derive. And in the derive window, that was the wrong button, sorry for that. This
Early
was
in the morning.
Yes. So here, you derive to an existing design. So you derive this component into an existing design. Then I just have to click this. So you can see that skeleton is used in the derive. And I have to check down here that favorites is checked in parameters. And I hit OK. And then I'm going to choose my new file, in this case, a compound shaft assembly, selecting that. So now if we look into the timeline down here, you can see a little white box with an arrow. That is a derive event in the timeline, which means that now I have in this compound shaft file, I have a ghost copy of the skeleton file, but not only that, I have access to the parameters. So if we go up in the menu and hit the parameters, I can unfold this, and here they are.
Ooh.
In all their glory.
Oh, we like to see that.
And I redid all this yesterday after the live stream to clean everything up. And I tried to unfavorite. So I think this is still not optimal from Fusion 360, because I tried to defavorite a parameter and favorite again, and then the link is lost. And then it creates doubles and stuff. So that is pretty horrible. So now, if I'm going to start to design in this file, so let me name this component. I can use the parameters also here. So 0201. No, this is actually 00 master sketch. Let me create with a plane at angle. On this line, you can hardly see it. There's a line from the derived. So this little plane, So this sketch plane will move around when we move things in the origin design. So let me just... If this works, it's great. If this start to crash and stuff, it's less great. Because then my whole design will like hang on this one thread, right? So just to show you the gist of it all here. Because for example, I'm gonna CAD now 2 gears, and I want 2 gears from different design files to be at the same location. And that's where this will come in handy. Let me just do this. No, I shouldn't do it like that. I should do it like this. So what I hope for in the best of all worlds is that I'm going to build a whole Marble Machine CAD design, Marble Machine 3 CAD design, like fully parametric, which means that even in the end Hannes 3000, when all the parts are there, I can like say, I want a crank like 5 centimeter higher, and all the parts should just magically adjust.
Ooh. Now that's the way to do it. Yoo-hoo!
140 kilo with feet up, no problem. So here I'm going to start to CAD. And also another like design principle, all my measurements goes to the center of stuff. So it doesn't matter if this gear is 36 millimeter wide. I don't start it like on the left side of the gear. I always measure to the middle this time around. So I start with like a middle line, and then I just make the shape of the gear here. And like often in when I've been CADing so far, I measure stuff to the edges of them, which is suboptimal. So just constrain it straight, and I'm just gonna drag this until it snaps into the triangle. So this part has nothing to do with the parametric stuff. I'll get to that very, very, very soon. So now we're gonna decide the diameter of this gear, and I also have a parameter for that. So here the fun begins. I'm choosing this line, the pitch diameter, and instead of entering a value here, I just put gear 1B pitch diameter.
There you have it. Nice.
But this is diameter, and now I'm entering the radius, so I have to divide that by 2. So divide by 2, and that's our value. And now come the important part. Here I go from the middle of the gear to the center point of the whole CAD design. Let me zoom in a little bit. And this is also parameter. So gear 1 distance. Boom. And if I'm going to create a physical body here, a new component.
Like you did with me.
After the iPad.
Yeah.
Compound shaft. And then use revolve. And revolve this profile along this edge. You can see we have a nice disc.
Yeah.
So this is a gear, but it's without teeth yet.
Okay. Right now we can take it to Slottsskogen and go some holes, right?
On fire. On point, on fire. What can I say? I actually want to have the shaft first. This is going to be O2.
I'm quickly going to read a nice comment here from the user Deleted. Since the quote-unquote end of the MMX, I've been trying to learn Fusion for myself. I'm getting there, but these days watching the live streams have been incredibly useful to me. Learning so much. Thank you, and a heart.
Oh, I love to hear this. Like, I love learning, and if I can share like my learning journey and we can learn together, that is even cooler than if we make like a finished machine that works. So thank you for that nice comment. And I can show you a trick right here. So I'm a little obsessed about cleanliness in the browser tree. So if I zoom in on the browser tree, you can see here that I have 0200, 0202, and I want 0201 to be before 0202 because I want them in order. So there's two ways I can do that. I can create a new component now and call that 0201, 0201. But as you can see, it's not at
early in the morning.
it's not at the correct place in the list. So what you have to do then is that you go down to your timeline and you just drag that component before the other one in time.
That makes sense.
And look here, they are in the correct position.
Boom.
You could also move the timeline back like this, juke, and create a component at that point in time, and it will end up at the correct place in the position. So compound shaft. I'm digressing a little bit from the global parameters. Hold the global parameters thought in your mind. We're going to be there very soon. I just have to revolve this shaft as well. I think like the best way to learn Fusion 360 is just to decide to do something that you need to do. Because that will like, okay, I want to build a shelf, like make the shelf. That's the best tutorial, I think. Just following tutorial and CADing like example parts, for me, that has been less efficient. Okay. So I need to prepare one more step before I can do the final demonstration of this. I need to create the master assembly file. So let's just save this 0000 machine 3 assembly. And in this assembly file, I'm now going to, I did this in the end of the stream yesterday, but I re-CADed everything from scratch yesterday evening because I wanted, there was some things that were not clean. So here you can see that I'm entering 2 different design files in a third design file. And they happen to line up immediately because we used the parameter. So if I now go back to our very first design, like the mother design, and I go into this list, now at a fingertip, I can change this to something absurd. Let's say a whole meter. And when I save this design, and we go over to the master, you get these little flags because some files are not updated. And when I update this, both gears should move in unison. There we go.
Whoa, magic!
So 2 separate design files are being controlled by this same parameter. And because I know these 2 gears, I always want them on the same plane. And this is like something I thought of yesterday, which is, I think is really cool. Like what to drive with parameters, you can decide. This is taking me a long time like to get into, but you can decide like from, if you really think about how something is meant to work. So I have another like nice example here. Is there a dog outside?
Just our friend sneezing.
Okay. So I made a fun mistake yesterday. So basically that's the end of the global parameter tutorial. Make one design, make your parameter list in that design, favorite all the parameters, derive that design into all the designs that you want to drive with the parameters from that design. That's the 12-second tutorial right there. But I want to show you something else that I thought was cool yesterday. So in this design, I have a master sketch. So I'm trying to use this sketch. I'm going to build the whole sub-assembly in one sketch, hopefully. And this right here is the shaft. And in the beginning, I did this. So I said, okay, I want a shaft length of, let's say, this measurement, 1068 centimeters, right? So I've said like how long I want the shaft to be, and I've constrained it to the middle of the whole CAD design. All good, looks great, right? And then something special happens when I go back into the first parameter here, and I change my mind where I want this gear. So actually I want this gear 1.5 meter out. You know, the machine is going to be super wide. So I save this. I go back to the crank thing. For like one small assembly, this way of working does not make sense. But for a complicated design like the marble machine, this will make sense in the end. So I update this here. And see, it breaks. Why does it break? Yeah, because the revolve command down here has become yellow, right? And why is that? Yeah, because this profile in the master sketch is not longer filled. Why is that? Yeah, because the shaft didn't alter with the parameter, because we defined the shaft length to the middle of the design. So the correct way to do this is to define, if we go back into this sketch, if you know that you're gonna drive this distance with a parameter, and you always want the shaft to be longer because the gear always need to be on the shaft, right? You make this length, hang on. So remove this. So you make the length of the shaft dependent on the parameter position. So instead I say, hang on a minute, you are 5 centimeters outside the gear at all times. So by adding the distance here instead to the middle of the design, the shaft will always change when I change the parameter of the gear position. So let's try this again. Now I think the timeline is fixed. So if we go back again to our parameter list and we move the gear further in, 300 millimeter, so just 30 centimeter from the middle. Boom, boom, boom. Let's go here. Now the shaft should follow the gear. Look at that.
Ooh,
isn't that beautiful?
that's a thing of beauty.
So like what I want to convey is like, try to think logically. Like these things are on this shaft, which means that the shaft length will always be longer than the gear, which means that the shaft length should be in relationship to where the gear is, not in relationship to the middle of the design. So yeah, those are my new findings, and we're gonna make a lot of designs today and see if Fusion is breaking down or not. And I'm gonna start to put in the drums and stuff and using parameters as well. Okay, I got that out of my system.
Yes, there we go. Now we can drink some. I just want to read a comment there from Nikhil Raj. I'm not a CAD expert or a musician or anything, but seeing Martin work hard non-stop towards his goal really inspired me to keep going. Pain is temporary, glory is forever. And I couldn't agree more. Even my t-shirt even says so here.
That's so nice. That t-shirt looked great on you, Hannes. It's
Thank you.
So metal. You like the Motorhead type.
Yes.
Type. Yeah, I think like this struggling with making a dream come true. I think that's the most relatable in what we're doing. Like the ins and outs of CAD parameters is maybe a little bit less so. So here is the blocked model that we did. And basically, I'm not working on this anymore. We did this almost on the first day. Yesterday, we made the machine much wider, and we actually even planned to have a full vibraphone, which makes us able to play things like that and key changes. So that's very exciting. We don't know how wide we're gonna make it, but what I want to do in this stream is that I want to like convert this model into a very serious like parametric model. So why not add, let's see where to start. Oh, cool thing. Crank height, for example. So I'm going to, because that's an ergonomical thing, I'm going to measure the crank height in the first machine. So I measure from the center of this down to the floor. 1042 should be to the center, right? Yeah. I think I'm gonna do 1040 just to keep even. And I actually have a parameter for that. So here is the crank thing. So, and that is also, if I put the origin here, wait, this looks, am I upside down? Okay, we're gonna find out what's happening here. No, the origin is there. It's good. We're good. The origin is in the middle of the programming wheel. So if I head into our list of parameters, I have crank distance to floor. So here, 1040. We take that from the machine X. Boom. And this has already changed in here, which means that when we go over to here, you will see this go up a little bit. There we go.
Oh, nice.
So now we have the floor. Now we have the same height of this shaft. And you can see all the parts are following. Everything is parametric and nice.
Wonderful.
And wonderful. And I'm also going to check from the original machine. Here. I'm also going to check programming wheel to floor. So let's measure this one down to the floor. 1522. I'm going to do 1520 then. So we head to our parameters. Where is it? Prog wheel distance to floor here. What did I say? 8. Do you remember?
No, I wasn't listening actually. I admit.
What?
I was reading especially like this information right here from Lucas Olsson when he says this is how we construct road/railway tunnels. Everything is parametric, controlled from a tunnel section and then swept across an alignment, then just change parameters for widening, etc. You see, marble machines and railroad tunnels.
That's so cool. Do we have like railroad tunnels engineers in the chat? That's why this is the best corner of the internet. Imagine feeling the power, like you're sitting on your computer and just like, I'm gonna make a hole through this mountain and there's gonna be trains through it. And you have that power in the top of your fingertips. So cool. I think I copied it this time. Distance to floor. Yeah, I copied the value because I knew I wouldn't remember it. I'm going to do 1520 just to keep things a little clean here in the beginning. And this has already changed and this has already changed. So hopefully by the end of this stream, I will have almost the whole gear train represented in our full assembly. So what should we put in now? Perhaps a representation of the programming wheel gear. Or maybe we should do this one. We should do, yeah, on, oh wait, we did that one. Yeah, let's keep let's keep getting the gears in, which means this shaft looks just a little bit short. Let's fix that here. So basically what I want now is that I want like a very simple blocked model that I still can control with all the parameters. So for example, we've been working a lot with, what's it called? Instrument positions and stuff. And I kind of want that to be, I want to start to find out like how many notes on the vibraphone we can have and stuff like that. And I want to build a very simple model that will help us with that.
Mm. And for those viewing that is wondering what the big red thingy is next to the machine, now that's a representation of Martin.
Was there a question?
Yeah. We measured him the other day, so it's pretty accurate.
So what should we put in next? If I update here, we should be up to date. Everything jumped around, like everything was moving there when I was updating. Everything has been updated. Okay, let's put gear number 2 in. And that is... I have a little new naming scheme for the gears. I call them 1 and 1B. That means 1 is connected to 1B, and then 2 and 2B. So this has the wrong name. This should be gear 1B. So new component 0203 gear 2. But I'm not putting the sketch into the new component. I'm just keep on working with my master sketch, which will keep things simple. And I think this should be on the inside or on the outside. I'll put it here for now. Yeah, like I've been saying, just because everything else in the previous machines have taken absolutely forever, I'm trying to remind myself about not being locked into this like slow thing. We were spending like 70% of our energy on YouTube,
Yeah,
and 30% on engineering. And that's why I'm so excited about what we're doing now. It feels like, we are spending the energy where it should go. So here already I have prepared to, I have gear 2 pitch diameter, boom, and the distance, same here. Gear 2, I don't have gear 2 distance. Okay, so I have to create that one. So as everything, like the more you prepare it in the beginning, like it's going to be a little like slowish in the beginning, but you'll have that back in the end. Gear 2 distance. Let's do 400. And I actually want to put gear 1 distance outside. So can I do I can do a parameter in the parameter, okay?
Oh, paraception.
So for example, if I want to put, if I know, because I just said that I wanted the gear 1 to be outside the gear 2. So then I just use gear 2 distance plus, say I know I want them to be 20 millimeters apart. Plus 20. Ooh. Let me zoom in on that. Are you seeing this?
I mean, this is mind-blowing right now.
Yes, so that's, again, like, this is new for me yesterday, so I'm telling it to you like you didn't know it, but I didn't know it yesterday. Is that you think like, what do you actually want the model to do? Yeah, I want this gear set to be always outside this gear set. Okay, so you actually want them to have a relationship, then you can program that relationship into the parameter list. I love it. Let's see if this works though. I talk a big game. Now I have to
Walk the walk.
Walk the walk. So this is going to be exciting to see how these are behaving. First of all, I have to save this file to make all the changes propagate through. I'm updating here before adding. Yeah, this one doesn't really know what to do right now, perhaps. Or it's maybe, we'll see. Here is gear to this. Oh, okay. This parameter has not yet come up here. And the reason why is because I haven't favored it from here. So I have to go into the parameter list and say like, go and get that one as well now, the new one. And then I will be able to use it. Gear to distance. Yeah. Did I say 20? Yeah, so I did wrong center. You can also see here that what I showed on the first one, this shaft should be to the middle of the outside gear. So let's say 50. So I think it's working. I just put a bad value in. So let's go over here. 20 is too little clearance because we have the thickness of the gears as well. And then we can do even cooler. So if we know... Oh, are you ready for this, Hannes 3000?
Yeah, I don't know. You tell me.
New parameter.
Oh.
Gear thickness.
Okay.
So this is...
Yes, here we go.
Gear thickness.
Expression. Anger.
36.
Okay.
Right now they're 36 millimeter. Just two 18 millimeter plywood. We'll see about this. But when we have it in a parameter, we will be able to change
it later.
Exactly. So, since these distances are all center, we're going to have gear distance. So this is how much space we want between them. Plus gear thickness.
What?
Plus... Exactly. Plus 20.
Okay.
So this means that now we have 20 millimeter clearance. If you saw before, the gears were sitting inside each other.
Yep.
So if this pans out...
Let's check it out.
Where was I? Here.
Update.
Ooh, it's so beautiful.
Oh, wow. I can't believe it.
20 millimeter, everyone.
Woof.
And what is cool now is that if we change the gear thickness, this 20 millimeter clearance will always be there. 20 millimeter exactly. So yeah, we always want that clearance. So now I have to actually go into my sketch and change here because this is just 36 now, but I don't want that. I want gear thickness. Oh, we don't have the parameter yet. Let's go and get it.
Oh, that's favorite. That's favorite.
I love you, Hannes 3000. Always with the support.
Yes.
Always with the support. I don't think you would have done 19 reps if I wasn't supporting you, though.
Yeah, you can take credit for my workout. That's fine.
Here, now, gear thickness. Boom. So I'm gonna change that everywhere.
Nice.
Gear thickness.
I have a nice question here from Jairo Cabello. How have you even survived so long in Fusion 360 without parametric designs?
I've been doing a little bit of parametric designs, but I think I haven't have my head around it. Basically, like, I was learning so much other stuff, so there wasn't space in my brain, I think. So I didn't even knew I needed it, but now I'm wondering the same. Where was we? Let's update this. Can I change this from here? Yes, I can. Okay, so this one doesn't have the parameter yet. Let's go and get them. Gear thickness. Yes.
Cogno Marco, you should create a clearance parameter and set it to 10 millimeters as per design requirements.
Good idea. This audience is skating where the puck is going.
Gretzky's are waking up in the chat right now.
In this case,
We broke him, everyone.
perhaps. I was cosplaying Elon Musk. I wasn't broken. I was cosplaying Elon Musk being broken. I'm gonna hold that thought. Because I think we might have a frame in between here. This is probably not a normal clearance situation, but we'll see that later. So good idea, but I'm not gonna do it right now. So now I'm gonna revolve this gear. Second gear here. Boom. So this gear will turn the loop machine, which means that we should make a new design. I'm just gonna flash this so everyone knows what we're working on. And yesterday we learned how to make helical gears. So these gears will eventually be helical. I think it will be the world's first helical plywood gears. But correct me if I'm wrong.
We'll take it.
0300 loop machine assembly. And so when I start this new design, I need to go back again and derive our master like we did in the beginning to get the sketches and the parameters from the master sketch. Destination, existing design, select this one, parameters, favorites, here we go, and select the loop machine assembly.
Have you saved in a while?
Yeah, I think I saved.
Oh, nice.
Let's go, let's make a save round.
Oh, yes. No.
Thanks for reminding.
Can I have cheers? Cheers to you, audience. Hope you're having a good time out there.
Yes. This message. Crankshaft assembly. Okay, I have to. I wasn't caring about this message yesterday. I think I have to go and save in another order. Let's cancel this. I don't think it matters actually, but let's see if Fusion is happier if I save this. I save this. I update this. So I don't understand this message actually. Crankshaft assembly version 15 has unsaved. I think I'm on version 16. So I didn't save. Okay, discard and update. Good. We can discard. It's it's talking about a previous version of the design. So now I want to create the gear that is going to mesh with this smaller gear here. And the cool thing in the end is that we will be able to change the gear sizes to get the correct gear ratios, and everything will follow dynamically. The shaft positions will move around. When we make a frame, the frame will also move around. Sometimes it feels like I'm explaining things for people who already get it, and the people who don't get it don't care.
It's good to remind yourself sometimes, okay?
Yeah, maybe that's what I'm doing. I'm like
making sure that you still understand it.
Yeah, I'm repeating it loudly.
Yeah.
Isn't that like, I think it's pretty interesting. I heard like it's a real method in science, like that like scientists has to do presentations for each other all the time, which means when they have to stand up like Friday at the end of the week and like present their work, they have to actually think how to formulate what they have actually done, and that's where they realize what they are finding out.
Yeah.
So like telling other people about what you're doing is kind of like a...
Yeah, you are a scientist.
Closeted scientist. No.
Rolofilm says rubber ducky principle. Is that something, perhaps?
Oh, I want to know more about this. What is this?
I will check it out.
Rubber duck principle? So another pet peeve of mine. True long-time viewers will hear this over and over again. When you want something straight, don't draw it straight, constrain it straight. So just draw your lines however, and just tell them what you want them to do with constraints. That way you will be sure that it's like the sketch. For example, I want it on this point, and then I tell this line to be coincident with that point. I tell this line to be coincident with that point. And this thickness of this shaft is also driven by a parameter somewhere.
Do you want to hear about the rubber duck principle, or as it's also called, rubber duck debugging?
Would love to.
In software engineering, rubber duck debugging is a method of debugging code by articulating a problem in spoken or written natural language. The name is a reference to a story in the book The Pragmatic Programmer, in which a programmer would carry around a rubber duck and debug their code by forcing themselves to explain it line by line to the duck. Many other terms exist for this technique, often involving different, usually inanimate objects or pets, such as a dog or a cat. Straight from Wikipedia.
Wow. Fantastic. Great stuff. So Gretzky rubber ducks out there. Happy to have you here.
Oh, I would want one of those.
So
Vanir says, I have a rubber duck on my desk at all times as a software engineer. So people are doing this. I love it.
It's happening. Do you know what else is happening?
Magic.
Parameters are happening, because I'm actually going to prepare this a little bit, because we have to look here, because these are pitch diameters of gears. So gear 2 has 200 here. Okay, good.
If people says you already have a rubber duck and it's Wilson, you know. That's what you have been doing for the last couple of years, talking to him.
That's true. So this is actually already the parameter. I'm gonna change the name. Gear 2B pitch dia. Pitch. It should actually only be pitch. I know what I mean. Okay, it become red. We already have it. Where? Yeah, I called another. I call this pitch, and then this one is actually gear 3. So 3.
Oh.
And now I can call this pitch dias. Okay.
You should call it pitch perfect, my friend.
On point, on fire. So now the fun thing is that I'm going to define this gear, and I will only add parameters. I will add 0 measurements. So let's start with the thickness. We all know the old, no, building it up and it's falling. The higher you are, the higher the fall, or what it's called. So maybe Fusion doesn't want you to maybe Fusion deliberately don't want you to have like a normal global parameters, because people would start to use it and then forget that they used it in other projects and then change the parameters and they go back to their old projects and everything is wrong. That could be one reason. Check this out now then.
People are saying a lot about snake case for parameters. That's how we define constant variables in code.
Snake case?
Yeah, I'm really not 100% sure about snake case. It's how you write the names, of course.
So gear 2 distance, and then, so we have gear thickness, we have gear 2 distance, and then we have the last one, gear 2B pitch dia. 300, this feels wrong.
Underscore, I guess, between everything.
Uh-huh.
That's snake casing.
Gear. Something feels wrong here. It should be bigger.
I'm learning stuff here as well.
It should be 800. Wait. Okay, so I'm a little bit confused. Gear. It's a gear 2B parameter. Let me just check the gear 2B pitch dia. Oh, it's just wrong. No. It's 800. Okay, so now we might gear 3 pitch dia. What have I used here? That's the gear 2B pitch dia. It says 800 here. So why is it giving me the wrong value? So maybe the party ends here. Ref. It's giving me the wrong value. Gear to pitch the 800, it says here. Do we have a double? Because that's happened yesterday. I had a double. Ref 1, yes, it's a double. Okay. So this is where we have to watch out. So you can see this is ref1 here, which means that we had... Oh, I used the same name, didn't I? Yes.
Oh, wow.
I changed the name, and this is what's messing this up. Because
Killian Ruckdy, Martin, you haven't saved the name change of the parameters. Could that be it?
I think I did, but the mistake... I think Fusion remembers all the parameters, even the parameters that you renamed and stuff. So what happened here... This is actually referencing... Yeah. So you should not rename another parameter something that another parameter has had as a name before. I think that's what's happening here. So let's just call this diam, gear pitch diam, just to completely go away from the thing that we already used before. It's a little messy. I'm saving this. Okay, I'm learning here. This makes me a little bit nervous if it's going to be very sensitive. So now I'm going to choose the diam. Okay,
We're breaking everything already.
Yeah, we're running into issues here. Oh, wait. Didn't I? It's here. Pitch diam, it's 800. This makes me nervous. Let's just put something else in. 400, you see that works. Maybe I should just make a new one. Yeah, you see, Fusion is not happy. This is a bug. Jeff Strater, can you fix it?
Now!
I love your software, but this would have been... Okay, so... Lesson learned, I think, just try to never rename stuff in the parameter list. I'm going to create a brand... Why are these not favorited? I'm gonna remove this one. I'm gonna try to forget like deprecated. And I'm gonna create a new one. Gear 2B pitch diameter. This is annoying. This is what I mean. It feels a little fragile. 800. I'm gonna change here to gear 2B pitch diameter. So yeah, okay, that works. Great. So we are taking ourselves out of this dead end. So let's finish this sketch. Let's go and get the new parameter. Here we have to get it there. Okay. And now gear pitch diameter. Thank you. Great.
Mr. Fixer.
And of course, we have to divide that parameter with 2 because it's the radius. So there we go. New component. Let's make a physical
And as
body.
Stephen Mayhew reminds us of, better in Fusion 360 than on the actual machine.
That's how I want to design this whole design process. It's free to fail, free in quotation mark to fail digitally. These were the things I did physically in the room with the Marble Machine X. These kind of changes. 01, I actually want that to be loop shaft. Then let's create another one. 0302 gear 2B. Gearing up to be beautiful. Boom. So let's go to our main assembly and see if we will have a gear that meshes with this small one here now. What do you think? No.
No.
Sideways, it is lining up neatly, but I think we have the wrong value on the gear 2 parameter. Let's head over to check that. So this is the gear 2. Gear 2 pitch dia. Oh, I haven't radiused it. I think I didn't divide it with 2. That could be the simple explanation. So let's head into the master sketch. It's twice as big. Why are we upside down? Yeah, look at this. It's the correct, but I have to divide it with 2. Now, if we are doing our work properly, these gears should line up after I save this. Save. Look at that. Gears are lining up.
Gears are lining up. I got a nice little greeting here from Join Us Huggabear. Greetings from Bohuslän. I actually did the live audio for Detektivbyrån in 2007 at Debaser, Malmö, opening for Shout Out Louds.
Wow.
A long time ago. Now I studied design at HDK. Cheers.
HDK.
Yep.
Högskolan för design och konst. So that's like a very prestigious like design art school kind of. And this is a sound engineer that we've been working with when we were playing with my first band. So thank you so much for great sound.
Yeah.
On the tour. Nice to see you here.
And also greeting here from D-Vibe. He says, been a fan since Detektivbyrån. Did you meet with the rest of Wintergatan and made music lately? Album plan, ? Keep it up. Hälsningar från Skövde.
Oh, nice. No, I'm in touch with all of them and more, and with the whole band. But like this Marble Machine has just taken over my whole life.
Yeah.
And like what I'm trying to do in this project that you're witnessing right now, actually we can actually show that. I can go and show you exactly what I'm trying to do if we head over here. So what I'm trying to do to see if I can get rid of being kidnapped by this project. So what I want to do is to finish the digital model of machine 3. If the CAD is promising, I'm going to manufacture a physical machine. If the CAD is not promising, that's when I will be able to give up on the idea.
Yeah.
So until then, I'm going to be all in on this.
Yeah.
To see if I can. Yeah.
And all the members have their own nice little side gigs now as well. I mean, Evelina has her amazing art, and David is competing in
Eurovision.
Yeah, he's a songwriter and producer now.
He just won like a big thing in the Swedish Eurovision, so he went to the final. So David Sandén from Wintergatan might, and the song is Fire, he might represent Sweden in the big Eurovision final.
Yeah, that's brilliant.
Super brilliant. So we have the shaft here. So the end of this shaft, I wonder... This one I really don't know yet. So I'm just gonna leave it like this. So if there's one thing I learned about myself, it's that I'm happiest when I can just allow myself to see what I can do by focusing on like one thing at a time. And this is why we made this. This is why we're live streaming, why we're not making videos. Although we are going to make one video per week to summarize the work for Wintergatan Wednesdays. That might be a short live stream also, like 10 minutes, everything that happened in 1 week in 10 minutes. Okay, we have... Let's make the next... We have the... Yeah, this is going great. Let's see what gear we should add now. I think we are going to add this intermediate gear here. But I can already tell that this is not working because we need this gear. So now it's a good demonstration to see if all my things are panning out here. This gear needs to be out of the way of this gear. It can't be in there. So...
And now people in chat is wondering what song and artist it was in Mellow that David has written. And the artist is Cornelia Jacobs and the song is Hold Me Closer. So Wintergatan represented there, kinda.
So fun. So what I want to do now is that I want this gear to not be in the same space as this gear. That won't physically work. So I should be able to just check this out. Oh. So by dragging this, I can kind of see all my shafts and all the gears should follow. So here the loop machine is very far off. Can we get this? Oh, here's maybe the solution. So this is kind of a dynamic way to find like the position for the whole gear train. Maybe I should check this value on the original machine. The distance between crank and programming wheel. Let's take that from the original machine first. Where is it here? So I want to know. I think I have to do it like this. I'm gonna project the center here. And the center here. And then I want to find out the distance here. 577. Let's do 580.
580.
Thank you. Programmed into Hannes 3000.
Yeah.
Okay, so we are in trouble here because I wanted it to be longer. I had 700. So the original was 580. Let's do 600. Oh, I can lower the loop machine. Here we go. So I want this gear out of the big gear. I just have to lower the loop machine. And this line down here represents the floor. So I can see that we have some space. So we do that in the parameter list. Loop machine to floor. 400. Oh, then it's touching the floor. But the gear is out. Gear is out. So Maybe the loop machine has to be a little bit smaller. Let's see what happens now if we drag stuff around.
Oh.
It looks cool now.
Yes.
Still. Can I do this in another way? Let's lift the loop machine. No, the loop machine can't be that close. Loop machine to floor 500. Let's give it 10 centimeter clearance. So what we could potentially do is that we could move this. This gear looks too big. Gear 1 pitch dia. Let's change that. So gear 1 pitch dia. So here's a good example. Like I can just work around with these, especially then we're gonna calculate. Look at that. It's also not. Actually, this one and this one also can't touch.
Slinga, are you taking into consideration with the gear ratio to have the loop machine spinning 4 times faster?
That's a perfect. That's the perfect point to make right now. Actually, so let's actually. You know what? Because at the moment I'm not, and we should already start to do that now. So this tells me that you heard the ratio from yesterday, which makes me very impressed that you remembered it.
Another Gretzky appears.
Yeah. So I'm just going to lock this here right now. I'm gonna save this. Basically, I just want all the gears in, but you were right. I don't have to fret about the position when I don't even have the correct ratios yet. So there you saw it was getting very much smaller. Now everything should fly around when I update this design. Look at that. You just see that flying around? And it was a warning. I don't have to care about that warning. So we have in our spreadsheet, we have the gear rates. Where do we have them? Here. Let me rename this. Gear ratio. Later I will do a documentation central on wintergatan.net, so where I will post all the design files and all the requirements and stuff. My files are so messy right now. I'm just gonna put them together. So this is the gear train that we had on the previous one. So from crank to loop machine, I think that will be 1/8 because, but then we are already, maybe that should just be 1/4 then. Because if we want 16 cranks per, then we should have gear ratio of 1/8. So should we try 1/4 plus 1/4?
Why not?
1/4 plus 1/4 equals 8, I think. So then we could even, if we want to be really fancy, then we can do. So gear 1 pitch dia starts the whole thing. Then we can base all the other values on that if we know the relationships, which means gear 1b pitch dia would then be gear 1 pitch dia multiplied by 4. Can I do that? Oh, yes.
William Merrill, why not set the gear ratios as parameters?
Yes, that's exactly what we're doing right now.
Ah, nice.
So, so we have this one first to start with, and then we just multiply the second gear by 4, which means that
Thomas Sesselman says 1/4 plus 1/4 is 1/2, not 1/8.
in like
Is it different now?
I think I'm not good at math, but that's not how it works with gears.
Gears exists out of math.
So one, two, 4. Oh wait, this is on a compound shaft, so this is not the same. This is getting tricky for me now, Hannes.
Oh yeah, I can see the gears turning inside your head right now.
1 to 4. Wait, so I want. So let's check. So you kind of multiply them, don't you? So 1 plus 4 plus 1 plus 4 on a compound gear train is actually 1 to 16. Yeah, but that's what I wanted, right? 8 times... Yeah, 16 cranks. Boom, that's 16. 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8. So 1, I think this will turn out correct. We will see. Which means that gear 2 pitch dia, which now is also 200 millimeter, we can drive gear 2b pitch diameter. This one happens to be exact, but we're gonna make it as a formula. So put gear 2 pitch dia multiply by 4. There we go. And right now they're not touching, so right now it's okay. But then we have to check the... Let's make all the gears. Let's see. I think I'm going to create the programming wheel gear. So just so we have them all represented. Did you see a small little shrinkage there? Oh. So we are going to create, first of all, we're going to create the in-between gear that I think we have to use. So 04, 04, 00, gear 3 assembly. Am I right on that? Yes. How are you feeling in your muscles, Hannes 3000?
The first 2 hours here, you get so stiff. I need to just crack my back a little bit. We'll be better after lunch, you know.
It costs to be on top.
You know, some trade-offs, you know.
Trade-offs. That's everything we're gonna do here. I actually forgot this little line. This small little line is very important in the pivot point of all these gears from the skeleton. I've seen that I have forgotten it on this gear, so I'm gonna add it right here. Oh, I have to go into the sketch first. Just adding a vertical line there. And that's the line I'm basing the sketch planes on. So if I delete that line later, everything will break. So just do not delete that line. So it appeared right there. So, no, 0400 master sketch. Feels great. This is really some foundational work for the Marble Machine 3. I'm taking for granted that most of everything we're doing today will be like disrupted throughout this process. But if I can like do my changes in this design and keep on like tweaking the same design, I'm going to be very, very happy.
Yes.
Project this line, hide that sketch, and then we have something to work with.
Eaton G911. Are we maintaining maximum hydration? Question mark. We strive for that at least. So cheers. You always forget. You always forget. You're so eager to jump back into canned. I feel it.
The thirst for revenge is burning in my mouth, Hannes 3000. That's what you're witnessing. Yeah. I think this is so much fun. And as I said in some other stream, like I've been so obsessed with how people I felt really like ashamed of like going so all out on the Marble Machine X and then just have to give it up and admitting the failure. It was not easy. And so I've been so like obsessed with what people think and stuff. Yeah. And now I just want to prove it to myself.
Yeah.
Which it's much better, I think, perspective to have. Or, as I said, I just want to know when I can give up. If we end up in a result here that makes me feel comfortable with giving up altogether, that's also a good result. Not as fun, but it's better than like doing sunken cost fallacy on the Marble Machine X the rest of my life.
Yeah, additional 10 years with your silver tape, just trying to patch things up on that one. Angle grinder and tape.
Yeah.
Can only take you so far, you know.
Gear 3 pitch dia divided by 2. Boom. Gear thickness. Boom.
Yes.
And oh, I'm stupid. This one should called. Oh no. This should have been 2C because they are connected on my new naming scheme. So this is gear 2 distance. I think I should get the naming scheme. Let me just revolve this so people see where we're going. 0401 gear to C shaft. Is that correct? Never mind. Never mind. I have the rocky music you played. Is that rocky?
I think so, yes. If it's on my training playlist, then it's probably Rocky we listen to.
Hannes was not happy with the gym playlist this morning.
No.
He said it was like a buffet with too many different kitchens. Like you have pizza, Indian food, and like Swedish husmanskost all mixed on one plate.
Yeah.
New metal, or what was it?
Yeah, strange new metal, you know. They can't decide what they want to sound like. Maybe I'm getting old, but you know. Pick something.
You were not happy.
No. I needed my own headphones.
I felt it sounded a little bit like Wintergatan. Too many parts in every song. Like we just like found like a nice groove, and then it's a breakdown. And you know what we should do after the breakdown? Let's follow up with 3 other kinds of breakdowns. And then just like a hard, like 8 bars of hard music in the end, and never repeat the wonderful riff you played in the intro. Okay, so we have the third one. I'm going to do something that I should have done years ago. If I show the dimensions in this view, we can kind of manipulate these forms out in this view, which is really nice. Let's go to the main assembly and just add this gear, and then we're gonna find out the naming issues. So inserting this gear, and look at this, it just plops into place.
Boom!
Exactly where we want it to be. Magical. Let's update this file. So if you're new to this live stream, we have actually mirrored the whole machine. I'm standing on the other side of the machine for more ergonomical playing on the bass. So my idea is that this side, we can put all the dangerous gears far away from my hands, and the audience is going to really look at a big clock mechanism. So a full gear train here on the displayed side. And I love this in so many ways, because you will see like my facial expression when like playing the music. You can see the machine and me like at the same time. That's great. Only issue is that the muting levers, I don't know where to put them. I don't know how to reach them.
Yet,
no.
We're getting there.
And I don't know if we're going to have a conveyor belt or anything. This is just blocking. So I want to be thorough. I want to call this gear by its correct name. Oh, wait. This is gear 2. And this is gear 2B. Yeah, I think this should be C, and then the programming wheel is D, actually.
Can we please just have one that's called Metal Gear later also? To please me.
Yes.
Yes, there we go.
Okay. We can do that. So what we discovered earlier in this stream is that if we change the name of parameters, Fusion gives us hell. So how should I do now when I want to change the name? I think I should just deprecate this one. Deprecated. we have a lot of deprecated ones. And I should create a new, and I'm gonna not favorite this one. I'm gonna create a new one that is called Gear to C pitch dia, 300 millimeters. And now we have to go out here and change this one to the new correctly named parameter. Gear to C. Good. Save this. And then we have to import this new thing. Gear 3, where is our... Oh, I have too many designs opened. It's not even visible in the tabs. Here we go. Gear 3. I'm gonna change this to gear. Oh yeah, I have to get it first. Now I have to update first. How are people feeling in the chat? Do they like the parameters?
Everybody is hyped. No. They definitely want a solid Metal Gear later on.
Okay.
They got my joke.
It's not turning up in the list, and it's because I think I forgot to favorite it. Yes. See here in the mother thing, you have to favorite it.
Lucas Olsson says Parameter IO is a plugin which might help you organize your parameters later.
Interesting. Is it a plugin for...
I guess for Fusion, right?
Oh my god. That sounds very interesting. So what does it help with? And we still don't have it here. Gear 2. Oh, I haven't. Then I have to go in here and then favorite as well in here. And then we have it in here.
Gyro Cabello says creating a solid naming convention of parameters is key. I would suggest to do the following exercise. Before creating a parameter, identify and reflect on the purpose of the parameter. This will save you from deprecated and parameter mess long term. Also, global parameters are cool, but keep global only what really needs to be global.
Yeah. That's like a super good...
Mic has been dropped.
That's a solid advice. I'm not going to like try to design the whole thing in that list, is what he means, and I think that's a really good advice.
Here we go. So Lucas Olsson continues on the plugin. He says it exports your parameters to Excel, then you can change names, etc., and import it from that file.
Interesting. That sounds like a good backup solution as well. So can you paste the public document link again, Hannes? I actually have it here. So this one where people were doing wonderful stuff yesterday.
Can you fix the screen?
So if you could paste a link to that software in the Excel sheet, and that would be great, and I will look it up outside the stream.
Here it comes, chat. And you were wonderful yesterday, so remember today, keep it nice and tidy in there.
So let's go to the master assembly. Let's see how we're doing. So it looks wrong, but I suspect I forgot to divide it. I forgot that it was a radius. I have to close some documents. This is our rotary CNC machine that we're developing to make the helical gears and the programming wheel. But I'm closing that for now so I can see a little bit better. So yeah, again, I forgot to divide this by 2. That's why the gear is not fitting main assembly.
And the viewers are divided here on, a lot of people are now team belt, like Matt Schoen says here. Instead, having belts and gearboxes.
So timing belts are they mean timing belts instead of gears. So please make the case for them. Why?
Oh, what have you done, Martin?
and gearboxes, because right now we have only a gearbox, so we don't want like belts and gearboxes, because then we have two things. Instead of only one.
Let's see what chat has to say. Ross Valtisbool. Hi from Australia. Great to see you back in maker mode again, Martin. Woo!
Thank you. Great to see you here. It's I'm honestly been so happy the last 2 days. Just happy trying to get my revenge on myself.
A lot of people are saying it's great for noise with the belt, because gears make a lot of noise. If you want to have it sound acoustically nice. And also Matt Schoen says that way you don't have to line everything up perfectly.
So flat belts are very, very silent. Teeth, timing belts with tooth is like making a constant note, like in my experience. And the helical gears are supposed to be more silent than spur gears.
Okay. And Elliot says belts, more silent, easier to tension.
We are definitely going to have a belt for the flywheel. Let's see here.
Reduces quote unquote lash.
The backlash.
Oh yeah, okay. Andrew Smith says, I think musical timing will be difficult with multiple slipping belts.
Yeah, they need to be timing belts with teeth. Let's see. 05, 0500. Master sketch.
And Paul, damage may be less likely if a marble gets trapped.
On the belts, yeah, that's a good point. All good points, by the way.
Yeah, there's a lot of pros and cons with both sides.
I'm deriving this master sketch again with the parameters and everything into our newly created programming wheel assembly. Which means that now when I'm in here, I can create a plane at an angle. on the programming wheel line, which is actually exactly on the origin. There.
Matt showing here. The larger idea is that belts or universal joints or whatever let you separate the problems, slice them down so they're easier to solve.
Yeah, so space-wise, a belt will allow you to put the shafts wherever. You can just make the belt longer and the gear ratio will be intact. So belts are definitely an option. I think they're pretty like sensitive to being tensioned, and when they're really hard tensioned, it's really hard to get them on and off. Like on the Martian X, it was like a struggle to get them on and off. So here.
Yeah, and I mean, you're the only one who actually has been like cranking and playing with these marble machines. You have some experience at least.
No, but the belts are like really an option. It's just, where is that stupid line? Here.
Drain 08. The gears didn't cause a problem on either of the last machines. I wouldn't worry about switching to belts.
The gears were actually never an issue. That's correct. Oh, I projected too many things. Can I remove this? Okay, here we go. That took me forever to find that little line. Same thing again, making the shaft. With the helical gears, something tells me that we will be able to have like almost no backlash, silent transmission. Anyway, Alex CNC says that helical gears are more silent, but perhaps a silent tooth timing belt is even more silent than a helical gear, especially when we come up to pretty many gears. So this is going to be the programming wheel gear. And also, like when you have a belt, you still have to have the gears. And on the other hand, you would be able to buy these, I think. But so I want to use standard solutions, which means that on this machine, as much as possible, I want to use standard parts. And that, I think, is maybe the best argument for the belts. Because you will have pulleys and belts in systems that are made for each other, and you could just order the ratios you want. But most often, oh, these are two lines. So let me actually note this conversation down in the design requirements, because I think it's worthy.
Please fix the screen.
Yes.
Yes.
It's worthy. Now don't be hasty.
Oh, sorry.
Hannes 3000. Gears versus belts. Pros, cons. It's a great The worst reason to use gears is because we used them on the previous machines.
And they actually worked.
Yeah, but just because we used them there, we shouldn't use them again as a main like reason to use them. Gear thickness. Oh, I have 0 parameters. Why is that? Because I haven't favorited them yet. So I only have to do this in the beginning of all the DDD. Here we go. So for example, with a belt, if you're going to get like 1 to 16th, if you're going to get a 1 to 16th, immediately, say from one gear to another thing, like for the loop machine, if we go and look at it, if we go and look at this, so from here to here, it has to be 60. If you want to have a belt immediately from the crank down to the loop machine, it has to be 16 times larger, which means that if we do some quick math here, say that we have 10 teeth on the first gear equals multiplied by 16 is 160. So you have to buy from somewhere a belt pulley which is like 80 centimeters big with like 16 teeth, and then you don't have a lot of reading on the first. You have a very, very tiny gear, so 10 is too little. So I would increase this to at least 20 teeth on the first gear. So you need a belt pulley with 320 teeth, and I don't think that exists. I think we're already like outside the standard part catalog, which means that if I'm going to ask like a professional to make custom stuff for me, that's going to cost a lot of money. But perhaps the timing belts, I'm actually not excluding it. But it's never as easy as just say like belts instead of gears. In this case, if you could do that, like go from here to there with one belt, even though it would make this like note, I do still think it will be more silent, perhaps.
Food for thought.
Food for thought. So let's go into the programming wheel gear. Now we should have the gear thickness here. Boom. And we're using the same distance here. We're using gear to distance. And we're using program gear. The radius of this is gear 2D. We don't even have this one yet. So let me head over to fix that one. Create new parameter. Gear to the pitch dia. Expression. Let's do it 1000 for now. Let's favorite here. And also the belt tension, in my experience, the belt tension is not that easy. then you either want your shafts to be like movable, so you can like tension by moving the shafts in and out from each other, which means that you have to have the bearing housings and everything movable. It's a big adjustability issue. Or you have to have a roller that rolls on the belt, and that roller also makes sound. So it's, I don't know. Gear 2D. Oh, I don't have it because I haven't favorited it.
I just want to show you a little video I found on Discord here.
Okay, cool.
Some posted speaking about these gears. These are kind of what we're working with now, right?
Oh, they have made them. I thought I was first. I wasn't first.
It's kind of like that, right?
It's exactly like that. Steve Garrison. Can you pull up the sound?
Perhaps there is no sound on this.
Have you just shifted them over, or how did he make them? Did he?
It looks cool though.
Oh, and there is actually the herringbone pattern as
He
well.
also made in this shape. This is kind of fun to watch as well. What happens here?
What? That's beautiful.
That's cool, no?
So, he has. Can I see the last one with the crank?
It's just regular gears, right? Or is it the oval ones? Shout out to Steve Garrison anyway.
Yeah.
And to JLJ.
For posting.
Yeah.
So
Cool.
I was like, it's never been done, helical gears. It's like in skateboarding, they say NBD, never been done. And everyone is like, there's no NBDs left. I thought I had one, but I didn't. Now, finally, gear 2D pitch diameter divided by 2. Here we go. And soon we have another shaft here. 0501. Frog shaft. Revolve. So I left one line, not a construction line. That's also really good to just make everything construction lines so your profiles are whole. So you don't have to choose multiple profiles when revolving and stuff. There we go. And let's create. And I know we're not doing aesthetical, but gears are cooler, right?
And Jairo Cabello here. Funny enough, those helicodial gears is the common design for car gearboxes in order to reduce noise.
Yep.
Straight gears are only used in race cars.
Oh, is that why they sound so loud? Good info. Yeah, I heard like they are to reduce noise. And honestly, on the Marble Machine X, like the timing belt and the gears were kind of making the same volume. And on that machine, we did have straight gears, which is the louder version of the gears. So I don't know. Why don't I see my... So the sketch has disappeared, of course, because I put it to be invisible. That was why. So let's revolve this gear around this axle. Let's make it yellow. And let's take this prog gear. Maybe we should cut some spokes in these just to gain some... It's going to be easier to see as well. I think I'm going to cut spokes in all of them. And soon I want to start to put drums in here, which will complicate matters. Insert prog wheel. Look at that. Correct position.
Woo!
Look at this gear train.
Chugga, chugga, chugga.
So yeah, so the loop machine is not in a good position. Oh, we haven't fixed the ratio to the programming wheel. So, I know how to fix that. This one should be equal size as this one.
And Dax Neoburn here, how did you sort out the long save delay? Is it fixed today?
Today has not been anything.
Okay, the computer has rested for a while.
And I haven't used a file with the rectangular sketch pattern.
Rectangular sketch patterns.
I'm on a crusade against rectangular sketch patterns. Let's first fix the gear ratio to the programming wheel, which we can then do in our main here. So gear 2 pitch diameter, gear 2C pitch diameter is going to be the same as gear 2B pitch diameter, which should be 200. No, what happened now? No, oh. No, like 2, not 2B. Gear 2 pitch diameter. There we go. So they're equal size right now. And then I want a relationship between this small little gear and the programming wheel gear, which is 1:8 again. So then we go here, and I say gear 2D, which is the prog gear, is... Oh, but that was 4. Maybe I lost it here. Gear 2 pitch dia, yes, times 8. 1600. Okay, so this is a little bit wrong. This has the wrong one. So 2D, this is gonna wreak havoc. Yeah, it doesn't even take it because the constraints are stopping us. So that's why we should actually... So right now, the programming wheel is not having the correct speed. How can we fix this?
Let's go to the danger zone. Get the need for speed.
So we have 1 to 4. Before I had 1 to 8. Okay, so let's start messing around with this. I think I have to revert. I think I have to solve the loop machine differently because the original solution for the programming wheel gear ratio was made much more sense. So let's start with making the absolute first. And now it's cool because now I'm going to change the size of the first gear. And that should change everything. So gear 1 pitch diameter. Let's make something smaller, like we can actually check on the original machine, like just to get in the ballpark of what we had. This is not 200 centimeters. Millimeters, I mean. From here to there. Yeah. We're in a sketch. From the bottom of this gear
to the bottom of my heart.
To here. 100 millimeters. Good. That makes me happy. That's why I can't fit stuff, because everything is like twice the size. So let's start from the first gear up here in our parameter list. And let's do a little chunkier. Let's do 120 millimeters. Look at this. Everything is changing. And pretty cool. I think now I changed one gear. Let's just go to the main assembly and just hammer home the point about global parameters and the power. So I changed one value, right? You saw me change one value. And this was our gear train. I'm hitting this magical button.
Oh!
It looks kind of horrible though.
But something happened.
What? Did it all of a sudden allow... Oh wait, it allowed the crazy 160 gear now. Okay, we'll fix that later. Almost.
Yeah, we almost hammered it home.
And then the second gear is not ×4 because we want ×8 because we want to use the classical relationship. You see, this gear went big now, which is cool. And what is the relationship to the loop machine now? So now I want to let's first take care of the programming wheel. So it's gear. Okay, I have to just go down on the size. I'm sorry for this. Hang on.
Yeah, that's actually a really good time to... We need to wrap it up now. We're gonna head out to lunch now.
Oh yeah, I have an appointment actually.
You have an appointment, so...
I just have to fix this first.
Oh,
I just
do it fast.
Yeah. I don't want to leave this hanging. I'm going to change gear. I want to change... Yeah, gear 2. I'm gonna do 120 on that one as well. And then things... should 960. This looks much better. And this is gear 2D pitch dia. Okay. I'm running late to my appointment.
It worked.
And we have learned so far so good. Fusion 360 is doing well with the global parameters. Thank you everyone for great advice in the chat, and we will be back right after lunch, adding more parts, adding the drums, adding some other parts.
Yeah, we will be back, and we even saw some super chats being up there in the chat.
Thank you so much.
Thank you so much for that.
That means a lot. We don't have Patreon, we don't have YouTube memberships. I couldn't take like having people paying monthly, and I didn't know if I could deliver. So if you feel that you're getting any value out of the streams and you leave us a super chat, we're super happy. And if you don't, we're also super happy. So thank you so much. I'm gonna run.
Yeah, see you after lunch. Take care, everyone.